Hello everyone, welcome to Geonodes Daily series where we do something cool in geometry nodes and we try to do it as fast as possible. And like the title said, today we are going to look at how to create fake metaballs. You can see from the demo that it's playing right now that you can achieve quite different results. As you can see, this chocolate sea looks completely different from the object that it's the center of attention. But they are done using the same techniques, just tweaking some values. So this is what we are going to look at today. If you are interested of the entire project and how it was made, check out the links in the descriptions to the first part, explaining the preset that it's used behind this, the mixed vectors and mixed floats, and the second part dealing with the morphing effect. Now I want to get the boring part out of the way. Boring but very important, the supporting of this channel, because this channel cannot go on without your help. So if you want to help me make better videos and present the content better, you can do that by placing comments with your suggestions and your feedback, and that would be much appreciated. Also, subscribing to the channel and liking the videos will make them be shown to more people, and that will make the channel grow. And of course, if you want to help me keep doing this, you can purchase the project files from Gumroad. And for this project, you will get what you see here. I'm gonna go in the fourth section, the bonus section, through the entire project, so you can see what went into it. So I'm not gonna waste anyone's time by doing that. We will just switch to this project that we left yesterday, where we created the morphing effect. This is going to work just fine on any point cloud that you create. As you can see, we have points here, so you can apply it to any project. If you want to see how this was obtained, you can simply go to the previous video. Like I said, you find the link in the description. One thing that I want to show you though, because I find it really annoying in other videos on other channels, when you see a cool effect and they use a preset and you don't know what's inside that preset, and I don't want to do that to you. I'm gonna show you what this mixed vector preset looks like. So even though you may decide not to watch the other videos or purchase the project file, you can see what went inside of it and replicate it. So this is the mixed vector preset, a really cool and useful one that circumvents some problems that you have with this mix RGB node. So let's move on to the first point, explaining the logic behind this, how you can create that fake metaballs. And for that, I'm gonna do something simple first. Let's take a grid, and I'm gonna connect it here, and let's put like 6 vertices, so it's kind of looking like this. And the secret is now to use those points. We can convert it to a volume, so now we get something like this. And then if we convert that volume back to a mesh, so points to volume and then volume to mesh, you kind of get this effect, because now you can start to play with the values, and you get that metaball looking effect. I assume you know what metaballs are, this object. If you don't, you can look it up. Anyway, it's basically allow you to create organic looking shapes. And the way we can control this, I will try not to go too much into details. Let me switch this to amount, is by playing with the voxel amount and the radius and the threshold. Given the fact that you can use these nodes separately to create gas volumes for this one, you have some overlapping functionality. The voxel amount basically controls the resolution of your volumetric shape, and the lower this value, the more they will interact with each other, and they will make like a more compact mass. And as you increase this value, so let's put 128 or 256, and we increase this, as you can see, you start to get distinct shapes out of it. And of course, you can control the radius of these ones, and as soon as they touch, you kind of get this interaction between the individual elements. In order to smooth everything, of course, you can use a set shade smooth at the end, because this ends up being a mesh. And this being a field value, that means you can give a different radius to each individual point. That's really important. If you want to create like a melting effect, so let me do something like this, and let's increase this resolution here. Let's decrease this one here, and let's get something like this. If you play with this threshold, you can make this dissolving effect, increasing the threshold. So that will be the basis of what we are going to create, explained on a lot simpler geometry. And like I said, and you saw in the demo, we kind of have two different looking surfaces, the chocolate sea and the object. So let's start with the object, see how we can make that one happening. Let's do this combo of point, if I can find the menu here, points to volume, and then volume to mesh. And now we get this blob, and here it becomes apparent why we need different settings, why I use different settings, because the trade-off when you play with this setting is that you lose details. So let's play with this one. Let's say increase this one to 128. Hopefully the system will not crash. So let me save this. And for this one, let's switch it to amount. And let's put something like the same, 128. And for the threshold, let's leave it at this for now. And let's get our detailed backs by reducing the radius of the points like 10 times. And as you can see, we start to get something happening here. And if we play with the threshold, we can see how we can get the melting effect. So if we put this threshold on, let's say, a small value, something like this, and of course add the set shade smooth, we kind of get this this result here. And of course, if we want to fill in the gaps, we can reduce this one the input, and we get something like this. And of course, if we reduce it even further, we can get a blocky effect. So let's leave it like this, and we get something that is looking like that here. Well, maybe increase it a little bit to get more details. And in order to fill in the gaps, let's add more points. If we go into our setup, this is the point cloud amount. Let's call this points amount. And I like to give it a color so I can find it immediately. And let's say we increase by 10,000 the number of points. And as you can see, now the mesh gets filled even more. So let's do like maybe something like this. Cool. Now it's just a matter of tweaking settings, and that's gonna be done at the end. But now we have a working organic object, and I want to show you how you can make that dripping effect that you saw in the demo, giving the impression that the chocolate is going down, it's dripping. And I'm sorry, we can do that by playing with the position of the vertices of this mesh. So let's do a set position here. I'm gonna plug this one here. Let's create a little bit more room for us to work with. And the way to do this is to distort this surface at the point level. So let's do a texture-based distortion. Take a noise texture and let's do an offset, something like this. And immediately you see this working. We have a few problems. First of all, things gets displaced. That always happens when you play with this noise type. So the way to fix that is to subtract 0.5, and that's going to make sure that the mesh doesn't move. The second thing that we want to control is the strength, because this is way too strong. So let's do a multiplication, and now this number here will control the strength. So let's do something fairly small, let's say 0.05, something like this. So we can see with or without, it seems almost unnoticeable, but this is what we actually need if we are to create the dripping effect. So one way to do this is switch this to 4D and animated this texture, but you get kind of like an uncontrollable effect, not to mention that this is more resource intensive. So we will do something else. We will play with the position of these points individually, because we do want a little bit of movement in this direction, but we want the downwards movement to be more intense to create that dripping effect. So like I said, we are going to affect the position. So let's take the position here. We will plug it here. Nothing happens because we have to do something to that position. So let's, for example, add something. And as soon as you do this, we can see this movement here and the movement on the y-axis, and then of course the movement on the z-axis going like this. So this is where we will plug our animation. For that, we can use input scene time, and that's going to give us either the frame or the second, whatever we want to do. So let's use the frame to plug it here. If we plug it directly, we're going to get something like this. So let's do combine XYZ, because we said we want to have different values for the Z location. Initially, we are going to plug everything here, but after that, we will do like a math, plug it this one here and switch it, for example, on multiply and do an increase on strength 3 times. So now if we look at this, we can see things start to give you the impression that they are moving down. Of course, the frame rate being very low, we kind of have a trouble seeing this effect. One more thing that is good to add will be a control for the speed. So let's do a multiplication, and now we have this control for the speed, and let's say make it 0.1, and then we can leave it like that for now. That will be the base of how you can do this. So if we do like 10 times here, the dripping will be a lot more obvious. I'm gonna leave it at 3 anyway. So let me save. And we can now play with these details of the noise texture. We don't want any roughness, we don't want any detail. We can play with the scale, we can increase the scale. Let's say like I used 8 in my setup. And you can add also a little bit of distortion if you want. That's gonna look very well on this. And as you can see, you can imagine things dripping down now. And it's just a matter of playing this setting, and this is the strength that you want for your effect. And then you have a speed control and all that good stuff. So here you go. Let's do now a different type of effect. Let's do the C to see to see how we can achieve a different look using the same technique. For that, we can actually let's remove our object. For that, we can actually use a grid like I showed you at the beginning, and let's connect this grid here. And we need to play a little bit with the setting of this one. Let's make it first a lot bigger, so we have a more surface to look play with. And then let's turn this into points, because we kind of want to have a random distribution of points on this surface. That's why we don't care about the vertex resolution. And now points are distributed in the random fashion, and that's gonna look great. Let's add more points to make the surface denser. And now we can do our combo, points to volume and volume to mesh. So let's add these ones here. Okay, now we can plug this one here. And let's do point to volume and then volume to mesh, and we get the surface here. And for this, we will play a little bit with the settings in a different way. We will play with the radius basically. So let me first do something to get a smooth surface. Of course, we will add the set shade smooth, and for the output, we can leave it like this for now. We are not going to play with these values. Let's play with the radius and see what's happening. What's going to happen? Let's take a random value, and I'm going to plug this into the radius. and let's say the minimum for the points will give a value, and we're gonna give a value for the maximum, something like this. And you can see immediately we get some dips here, and if we play with this value we can decide just how much imperfection our surface has. So let's leave it like this. We get a little bit of imperfection, and of course we can play with these values to get different effects. Something else I want to show you, it's how you can make this sea to wave, like you saw in the demo. And for that, we will play with the points, these points here, before we turn them into a volume. So if I take these two nodes, we will start to move these points around before turning them into a volume, and that's going to give us a very interesting effect. So let's do that. I'm gonna do a geometry, set position, plug it here, and now we'll play with this offset value here. You can see if we start to move things around, you see what's happening as the points reconnect with each other. We kind of get a movement of the surface. So we will use that to create our effect. And of course, being animated, we will need the scene time. So let's take the scene time here, and then let's do a vector, combine XYZ. That will give us control on different axes. So then we can plug this here. And as you can see, everything disappears because our sea gets moved to this location that we have here. So immediately we realize that we need to add some controls for this to control the range. And for that, we can use a math node, and let's switch it to ping pong. And now we can have a control for the scale. So let's plug in a value here. You can find it in the input value. And let's say 2 for now. The important thing here is to make sure that your C stays in the camera. So this value will be dependent on that. But for now, I'm just gonna do this. Leave it on 2, plug this one here, plug this one here, and now we get this effect. Things are staying within this boundary of 2 meters. But of course, there is something else that we need. Can you guess it? Yep. We need a speed control. So let's switch this to multiply. And now we can do something like this and get a control of the speed. So what happens if we want to control this speed individually? Well, we can do something like this. Let's do a vector, separate XYZ. So we can plug this one here instead of this one, and then we can do a vector math node here, and we can use the frame here, do a multiplication, and that will allow us to do different speeds for different axes. So let's say that I want something really small on that range and something maybe faster here. Let's divide it by 10. I think it's gonna look better. Yeah, something like this. And now we get something going on for us. Cool. Of course, playing with these values is gonna give us different effects. For example, playing more with this value is gonna give us this kind of a look. So you can use that to get the surface looking the way you want it to look. So what if we want to add more values? We want to add more control to this and more variation. So let's say I want to make sure that I don't get the same values everywhere. So we can get something like more intense values here, less intense in another place. Well, we can do a vector math and we can add a random value here. So let's take a random node, switch this one to vector and add some values here. And as you can see, immediately we kind of get something looking different. So let's say we play a little bit with these values and make sure they are not too intense, something like this. And you can see the difference. Instead of having everything move together, we can have something that has a lot more variation built into it. So here you go. I think I'm gonna stop here with this because we can actually see exactly what I did in the final part where I'm gonna go around, do a run through the entire project. So quickly, I want to show you how you can make the contact surface actually. Because if we combine these two, let's do a geometry, join geometry, and we can add our mesh, monkey mesh here. And the monkey mesh is down, so let's quickly just push it up so we can actually see it. Something like this. And maybe rotate it a little bit and move it down, something like this. The difference between the surfaces is immediately apparent. So what I did in the final setup was to add an intermediate surface that it's building a contact surface between these two. And I did that by creating another surface area. So let's look into that now. So the way we can create that contact area surface, it's we can take the points from the sea and check out the proximity to the points from the mesh. And based on a threshold, we can retain only the points that are closed around the mesh. And for that, of course, we will use a geometry proximity. So we will take the points of the C and let's close everything, and then we will use actually the geometry from here, the geometry of our mesh, and we will then delete the points. So now we can use this information from the C to decide which points get deleted. So for that, we can use a compare node, take the distance that will be calculated between this geometry, the C, and this is the C, and the distance to our object will be calculated at the point level. So we can use that information. And let's say all the points that are not equal to a certain value gets deleted. And points that will not be deleted are the ones that are within a certain distance of a certain distance to our mesh. As you can see, we can get now this surface. Let's make it round, something like this. So this will be the mesh that it's surrounding our mesh, basically. Excellent. So now we can do again this combo of points to volume and volume to mesh. So let's take these two nodes here and we can connect it like this. And now we get this surface. So let's play a little bit with the settings to get us in between surface, smoothness wise. We can also play with the threshold to get rid of some of this information. So let's make something like this maybe. And of course, we can play with the other values to reduce the surface and get something looking closer to what we want. And now we can simply rejoin the surfaces. And as you can see, now we have contact surface that we can play with. So if this surface is moving, then the contact surface is moving. And if we move this geometry, that's also gonna move with it and create this in-between surface that we can control by playing with these settings. So that will be all for this project. But like I said, I'm gonna show you the entire project now. I'm gonna go through the settings and stuff like that, so you can see the final result. So even if you don't purchase the project file, you can see what went inside of it and you can recreate it exactly. So let's do just that now. So this is the project file that you can find on Gumroad. A quick run through the parameters. You can choose any object to be here in the as a hero object instead of the monkey. You will still get the chocolate and the torus. These are built into the project. Then you have the ability to lift or lower the object into the sea and to do some rotation on the object, so you can do different composition on the camera. You can also move the sea up and down. You can change the speed of the sea, the waves on the sea, the chocolate sea, and the smoothness by controlling these parameters. You can add or remove the bumps, as you saw earlier, by playing with this parameter. Also, this is practically the number of voxels that compose your object, so how detailed it is, the resolution. And you have two controls, one for the morphing effect, like you saw in the demo, and one for the melting effect. And of course, we can control the dripping speed, meaning how fast the chocolate seems to go down. So let's now look at all of this in detail. We have the hero object that can be any object you want, and in order to make sure that we don't mess things up, because if we implement an object from outside, we don't know how big it is. So we have this setup that it's taking the boundary box of the object and doing this math to make sure that the object will be approximately 2 meters, no matter how big it is. That's important because of the way the entire setup is built up. We use points that are within a cube, so we might have to make sure that our object is inside of cube, because if it's going outside, it's going to be clipped. That's why we did this. Get the diagonal, the length divided by 4, and we get this procedural setup that makes sure that our object is going to be inside of the points we use to create the organic shape fake metaballs. This is how the torus object, the donut, was created. And of course, we have this chocolate bar. Actually, this is one mistake, the naming here. This is the chocolate bar. I showed you in one of the previous videos how to create that shape. As you can see, we have a mask here that selects the top of a cube that we have here, and then we do extrude and scale elements to create that chocolate shape that looks something like this. Yeah, it's good that procedural modeling is better than drawing. Okay, so this is the chocolate bar. In order to avoid the weirdness that you get when you start to morph from one shape to another, weirdness that consists in points bunching up in a certain place, or having incomplete shape that has missing parts, due to the fact that different objects will have a different number of points based on their size and other factors. We actually circumvented everything by creating our own point clouds, starting with the line, and that gives us precise control over the number of points that we want. And then we turn everything into points to use with our fake metaballs. And we spread the points into a cube by doing a random vector with some parameters that we will be looking at right now. So we got a point of clouds in a cubic shape. You can get a spherical shape if you want, and that's no problem, but I thought cube is better. It goes well with the bounding box. So for the point spread, we did this setup that controls the melting effect. Basically, by controlling how far we spread the points. If we have the object here and we use this setup to shrink basically the point cloud, we will get it be like this or like this, and that's gonna cut pieces of our object. It is intentional, and it is this control here, and that's giving us, if we look at this effect, let's put something like this, and we play with the melting effect, you get this. Let me do it slower. We start to melt the object because of this setup here. We can play with the distance. and effectively shrink the point cloud box. Now we go to the morphing effect. We have this mixed vector preset that I showed you at the beginning. It looks like this. And we use two of them to control the morphing effect. First, we morph between our torus and the chocolate bar, and then we morph the result of that between by me adding the hero object, the monkey or whatever you wanted, and we creating this cool setup that allowed us to get different results during morphing. So you can play with these values and get completely different result. I show you in the previous videos that you can play with the clump values, and you can even plug some random values here, or you can take another shape and plug it here to get a different morphing effect. The way, something that I forgot to mention, the way we can use these point clouds with our shapes is using geometry proximity that will make the points stick, will redistribute these points that are in a cube, will make them stick to our shape, be it whatever that shape is. So this is what it's happening here, controlled by this set position node. So basically we take the surface of the shapes that we want, and we make the points from this point cloud, the cubic point cloud, stick to that surface, and then we just move the points around. This is a setup to make sure that we can elevate our object. Is this control from here, this elevation, and then we get to the part that we did today, the chocolate C and the voxel control. So if we look at the chocolate C, I exposed some parameters here, allowing us to move the sea level up and down, and then we did the animation, and I exposed this speed control, so we can control how fast the waves are moving. Apart from that, these are just the final settings that we used. This is something we created today, nothing special. And this is the turning into voxels, into fake metaballs part. We played with radius to get different chunks into the sea, so we get different results if things are not exactly the same. This will be the final settings. I, of course, added the materials that we will see in a different video. And then we have this contact area for melting that we did also today. And these are the final values used. And of course, this is the setup for the hero object, the monkey. This is the animation, part of the dripping that we can see here. And the interesting thing here, I exposed for the melting effect. I correlated the values of the number of voxels that we use input and output. So when we start to melt things, we get lower resolution voxels, and also by controlling the threshold, as you can see here. In these points, we make sure that we keep a threshold that it's kind of close to these values that you see here. Very small values, 0.1 or 0.5, because if we increase the threshold and we get to 1, we basically dissolve the object. So I made sure that we don't start to dissolve it until very late, like when we are almost at the end of the slider, this 0 to 1 slider. Otherwise, the object will disappear too fast. But this way, we reduce the resolution of the voxels. We also shrink the box. That's gonna start to cut the object, as you can see at the ends. And as we push this slider, let's say like 0.8 here, we can see that the resolution is a lot smaller, and points are still here because we didn't play with the threshold. But as soon as we go to these values, we start to lose more and more of this because of the threshold. That is basically cutting out points from our voxel. So I guess this is everything. Yeah, this is everything. And if you have the project, you have this short explanation of the naming convention, so it will help you, and the colors used, so it will help you navigate through the project faster. For example, purple is a procedural animation. So if you see a purple frame, you know what that means. Orange is a transform, so you can identify the morphing easily. Black and white is a mask, so you can see this is a mask that is masking part of the effect, and stuff like that. You can understand the naming convention, for example, what they mean and how you can use them. Anyway, I will stop here. This again was a long video, so thank you very much for sticking it to the end. Hope you find this information useful. If you do, don't forget you can help this channel by commenting on the videos, giving your feedback, liking the videos, subscribing, and of course purchasing these project files. So until the next video, have a nice time and happily